Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 14, Atoms, Molecules, and Ions, Part 1. We are now in Chapter 2 of your textbook. Here are our objectives for today's video. Pause here. So as you may have been able to tell from the title of this video, we're going to get into some of the more fundamental aspects of matter. So we're going to start with just understanding really the structure of the atom in a little bit of a different way than we did last video. We'll start with the law of definite proportions, which isn't something we're going to be doing a ton with. It's something that seems really, really trivial to students because you grew up with this concept, but to scientists at the time that this was discovered, it wasn't trivial. So a given compound will always have the same proportion of elements by mass. It's also going to be the same by atoms, but what that means, if I have a sample of CO2, and you don't need to worry about where I got these numbers from, but it is about 27.3% carbon by mass and the rest being oxygen. No matter where I go in the universe, if I have CO2, it'll be about 27.3% carbon by mass. Pause here. So we're going to use Dalton's atomic theory to sort of understand matter, although there are actually some limitations to it. But by and large, this is a theory that has held the test of time. First being all matter is made up of tiny particles called atoms that you already know. The second point, the atoms of a given element are identical. This is not 100% true because you can have what's called an isotope, but it is still a useful concept. The difference between isotopes is just the mass. It's not going to change the chemical properties. The third being chemical compounds form when atoms of different elements combine. You should already know. And then chemical reactions involve the rearrangement of atoms, not the creation of atoms, not the destruction of atoms, because of the law of conservation of mass. Pause here. So we're going to be talking about the subatomic particles, as you may have already guessed. So we just need to do a quick review of them. So protons, they have a positive charge and a mass of 1 AMU. That stands for atomic mass unit. It is approximately 10 to the negative 27 kilograms. I could be wrong on that. I'll have to look that up later. And then neutrons, they have a neutral charge and a mass of 1 AMU. And electrons have a negative charge and are essentially massless. They do have some mass, but they are about 1/10,000th of that of a proton or neutron. So we can consider them to be massless, even though they do have some mass to them. Pause here. So this you should already know, but we're going to sometimes use the letter Z to represent the atomic number. It's the number of protons in the atom's nucleus, and that is the only thing that determines what the element of something is. So it's only the number of protons, not neutrons, not electrons. Pause here. And then the mass number, which you'll sometimes see represented by the letter A, that is the sum of the protons plus the neutrons. It will always be an integer. The mass number and that number on the periodic table are a little bit different from one another. The number on the periodic table at the bottom, which is related to the mass, is the weighted average of the mass numbers of all of the isotopes. So we're talking about specific isotopes when we talk about the mass number. Pause here. So sometimes we want to be able to quickly represent a specific isotope of an element. So we're going to use the full atomic symbols. So at the top is the mass number, so protons plus neutrons. At the bottom is the atomic number. You will sometimes see that left off. For the time being, don't do that. And then X is just a symbol from the periodic table. Let's work through this. All right, so the question says that it is carbon. So I go to my periodic table, I find carbon, and I see that its atomic number is 6. And then the question tells me that the mass number is 13. So I just put 13 there. And then it's carbon, so I do C. And then for the number of neutrons, it's just 13 minus 6, so 7 neutrons. All right, that is all for today's video. Thank you so much for watching and have a great night.